Hey guys, so this is a continuation of the last lesson that I taught, which is solving rational equations. Those first few that I showed you last time were kind of like basic ones. So now they're going to get a little bit harder where there's a couple steps you have to do first before you cross multiply. Okay, so here we go. All right, so I have some steps written out. I wrote an explanation of when we would do this. And so what happens is sometimes we will have a rational equation that will have more than one fraction on one side. So basically, so far, we've just automatically gone straight to cross multiplying. But sometimes you might have like one or two fractions being added or subtracted on the left or the right, and we can't go straight to cross multiplying. So that brings us to this bullet. When this happens, you first have to combine the fractions on that side. So if it's on the left, you combine the fractions on the left. If it's on the right, you combine the fractions on the right. Now remember, when you're combining fractions, essentially you're adding and subtracting them. So we have to think about adding and subtracting rational expressions. That was the last topic that we did last week. So to do that, your fractions must have a common denominator. Remember, to get a common denominator, you figure out what it should be first, and then you multiply one or both fractions by something, top and bottom, add the numerators, keep the denominators the same. So once you get to that point, once you've combined the fractions, then you can just simply cross multiply like we've been doing. Okay, so I have 6 examples that we're going to do. This first one right here, notice this is what I was talking about when I said has sometimes they have more than one fraction. See how on this left side there's 2 fractions there on the left side of the equal sign? So we could not go straight to cross multiplying right here. So what we're going to do first is we have to add the left side. So in order to do that, they have to have a common denominator. Remember, to get a common denominator, you want to think about numbers that they both go into evenly. So 9 and 3, the common denominator would be 9. So to get them to be 9, we're going to multiply this 1/3, the top and the bottom, by 3. And then I'm going to rewrite it. So this is going to become 7x over 9 plus 3 over 9 equals x minus 1 over 2. So I made them have a common denominator. That was our step 1. Step 2 is add the numerators. So we're just going to add 7x and 3, which those actually are not like terms, so it's just 7x plus 3 over 9. And the right side stays x minus 1 over 2. Now this looks like the problems that we did last time. So now we can go to step 3, which is cross multiply. Remember, to cross multiply, I'm going to do 9 times x minus 1, and I'm going to do 2 times 7x plus 3. So I'm going to finish this over here on this right-hand side. So I'm going to have 9 and then x minus 1 equals 2 and then 7x plus 3. Okay, so from here you have to distribute both of them. Sorry, this is so squished. So then we have 9x minus 9 equals 14x plus 6. Now that we've successfully cross multiplied, we're going to do step 4, which is solve the remaining equation. So we're going to get our x's on the same side and our constants on the same side. So I'm going to subtract 9x, bring it over here to the right-hand side. So that's negative 9 equals 5x plus 6. And I'm going to subtract 6. So this is negative 15 equals 5x. Lastly, we're dividing by 5. So x equals negative 3. Okay, so it takes a couple more steps at first. You have to combine those fractions, add or subtract them, and then you cross multiply. All right, so that's example 1. The rest are pretty similar, just different variations of it. Okay, here's example 2. So notice again on the left-hand side here, we have 2 fractions. So we have to add those together. In order to do that, they need a common denominator. So here's when we're going to have to multiply both equations by something, because 2 doesn't go evenly into 3, and 3 obviously doesn't go into 2. However, 3 and 2 do both go into 6. So we're going to make those denominators 6. So for the 3, I'm going to multiply top and bottom by 2. For the 2, I'm going to multiply top and bottom by 3. Okay, so first I'm just going to show each one separately. So this left one becomes 2 and then w minus 3. over 6 plus 3w over 6 equals w plus 4 over 2. Okay, so now I can just add the numerators. Before I do that, I have to distribute here. So this really becomes 2w minus 6, which I have to combine with the 3w. So we're just going to combine like terms. 2w and 3w would be 5w. And then the minus 6 stays the same. The 6 on the bottom stays the same. It does not become a 12. And so now here's our proportion. At this point, we would just cross multiply. One thing I want to point out is these two denominators do not need to be the same. That doesn't matter because they're on different sides of the equal sign, and we're going to just cross multiply. So now I'm going to do 6 times w plus 4 and 2 times 5w minus 6. We'll do this over here. So 2 and then 5w minus 6 equals 6 and then w plus 4. Okay, so now we're going to distribute. So this becomes 10w minus 12 equals 6w plus 24. Redistribute both of these. Now we need to bring the x's on the same side and the constants on the same side. So I'm going to bring the 6w rather to the left. I'm going to bring that 12 over to the right. So we end up with 4w equals 36. Lastly, divide by 4. So we get w equals 9 for this one. All right, that's example 2. A few more. Okay, here's example 3. So notice this time the multiple fractions are on the right side. So it doesn't matter which side they're on, whichever side. I mean, you could actually probably get them where they're both on both sides, where you have two fractions on both sides. I'll probably keep it pretty simple for you and just do them where there's only two fractions on one side to make it a little bit easier. So anyway, we're going to have to make these have the same denominator. So the common denominator here is going to be 2. So we're going to multiply this left one, bottom and top, by 2. So this becomes 10h over 8 equals 6h over 4 minus 1 over 4. Then we have to combine these. 6h and negative 1 actually are not like terms. So we're just going to rewrite this as 6h minus 1 over 4. And then over here we have 10h over 8. Okay, at this point we are now cross multiplying, just like we've been doing. So this becomes 8 and then 6h minus 1 equals 4 times 10h, which I guess we could have just gone straight to saying is 40h. And then on the left side, we're just distributing. So this is 48h minus 8. All right, so now we need the h's on the same side. So I'm going to bring this 48h over to the right by subtracting. So then we have negative 8 equals negative 8h. Lastly, we're dividing by negative 8. So we get h equals positive 1. Okay, and that's our answer for number 3. Okay, next, number 4. 4, 5, and 6 are going to end up being quadratics. So remember with those, once you cross multiply, you bring everything to one side if you get a quadratic and you factor. So I wanted to give you one like number 4 where the two fractions on the left side, or whichever side, the left side in this case, already have a common denominator. So like we don't have to do anything to get these to be the same because they already are the same. So what we're going to do is go straight to combining the top, which those are not like terms, but that's just g minus 2 on the top. The bottom stays g plus 2. So then we have 5 over g plus 4 on the right. So now we're at the point where we can cross multiply. So we're doing these two and these two. Keep in mind that these are binomials here. So you want to put them in parentheses. And so the reason why we want to do that is because when we multiply them, we have g minus 2 times g plus 4. You want them in parentheses. And then we have 5 times g plus 2. Now, on this left side with the two binomials here, to multiply two binomials, remember you have to double distribute or FOIL. So we're going to do g times g is g squared. g times 4 is 4g. Negative 2 times g is negative 2g. Negative 2 times 4 is negative 8. Over here, we're just distributing, so this is 5g plus 10. Okay, on the left-hand side, we have to combine these like terms. I'm going to finish this up here. Okay, so this becomes g squared plus 2g minus 8 equals 5g plus 10. Okay, so since we have a quadratic, which remember is just anytime you have an exponent of 2, which is what we have right here, we need to bring everything to the same side and factor. The side you want to bring it on is wherever that quadratic is. So I'm going to bring everything to the left side. So I'm going to subtract 5g, and then I'm going to subtract 10. So this left side now becomes g squared minus 3g minus 18 equals 0. Once you bring everything to one side, then you typically will have a trinomial. If we didn't have a trinomial, you would just want to factor by GCF. This one's a trinomial though, so we want numbers that multiply to negative 18, add to negative 3, which are g minus 6 and g plus 3. Our very last step, and I think this is where some of you forgot to finish in the last practice, was you have to solve now. So now to solve, we have to think about what would make this one 0, what would make that one 0. And if you want to, you can set up the equations like g minus 6 equals 0, which would be g equals 6. So that's one answer. And then this one would be g plus 3 equals 0, where once you solve, you would get negative 3. So these, for the most part, are going to have two answers. Okay, so that's number 4. Okay, next, number 5. So for number 5, we have two fractions on the left, and so we have to make those the same. We need the common denominator. Common denominator here is going to be 4a. So I'm going to multiply the bottom by a and the top by a, which this becomes 1a. You don't really have to put the 1 if you don't want to, over 4a plus 1 over 4a equals 3 over 2a. Okay, so now I'm just going to add these tops, which again, these are not like terms. So I'm just going to write a plus 1 over 4a equals 3. Okay, sorry about that. Had to get the dog under control. She's still barking a little bit, but I cut out all of the really crazy barking. Okay, anyway, so now that we've added those numerators, which again, they weren't like terms, so we just left at a plus 1. Now we can cross multiply. So we're going to multiply these two and then these two. So we have 2a and then a plus 1. And then 3 times 4a, which is just 12a. So now we're going to distribute. So this is going to be 2a squared plus 2a. And then 12a on the right. Notice we have a quadratic again. So now we have to bring this 12a over to the left-hand side where that quadratic is. So this is 2a squared minus 10a equals 0. So notice that this one is a little bit different than the last one because this is not a trinomial. So this is a binomial. So you want to look for a GCF, which in this case is 2a, and you want to take out a 2a. So they're not always going to be trinomials. Okay, then from here we are going to solve. So this would be 2a equals 0. If we divide by 2, we get a equals 0 as one of our answers. And then for the a minus 5, that would be just a plain 5. So those are our two answers for number 5. Okay, last one, number 6. So this time on the right-hand side is where we have our two fractions. Remember, in order to get these to be the same, if you can factor, you do want to factor. So this one here is 4 times x minus 1. That way you can easily compare it to this one and see that they do have that x minus 1 in common, but the right-hand side just needs a 4. So I'm going to multiply the bottom by 4 and the top by 4. So this becomes x over 8 equals 11 over, I'm going to write it back at 4x minus 4 now. It makes it easier for cross multiplying, minus 8 times 4x minus 4. Okay, now that I have a common denominator, we're just going to subtract the top. So I have x over 8 equals 3 over 4x minus 4. So now it's a regular proportion where we are going to cross multiply. So we'll do this over here on the right-hand side. So that's going to be x and then 4x minus 4 equals 8 times 3, which is 24. Now we're just going to solve. So I'm going to distribute here. Remember, x times 4x is 4x squared. X times negative 4 is negative 4x equals 24. Since our quadratic, again, is on the left-hand side, we're going to bring the 24 over to the left. We want to bring everything to one side. I'm going to rewrite it. This is a trinomial. Now, this one might look a little trickier because this leading coefficient is bigger than 1. But notice, which normally we would do like grouping or box method, but notice that these are all divisible by 4. So we can just take out a 4. So we're going to take out a 4. Remember, 4 is the GCF, and that's how we take it out. Then from here, we have a trinomial. So right here, what's left over in the parentheses is a trinomial. So now we can factor that into two binomials. So we want numbers that multiply to negative 4 and add to negative 1. Not negative 4. Multiply to negative 6, and add to negative 1, which is going to be negative 3 and positive 2. Okay, then lastly, to solve, we're going to set each of these equal to 0. For solving, we don't need to worry about this because there's no x there. So there's nothing with that in our solving. This is just going to be x equals 3, and this is x equals negative 2. So if you wrote equations, set each of these equal to 0, and solved, you would get 3 and negative 2. Okay, so that's the lesson for today. If you have questions, feel free to email me, or you can join our Zoom session, which is at 11. All right, that's a Reynolds wrap.